Have not figured it out?
I couldn't.
Well, then you haven't figured it out if you can't explain it.
I know, I was just under a lot of pressure.
Can anyone explain to us how because if you can't figure out the rest of the terms, it is really hard to write the equation. How did I find the rest of those numbers for the 5th, 6th, 7th, 8th, or 5th, 6th, 7th, and 8th term?
It's multiplying by 3.
Close.
-3.
That's what I meant.
Notice if I do, if I multiply by -3, that's how I get to each of those numbers. So I just continue that pattern. Now, what do we call a multiplicative rate of change, though?
Geometric?
It's a geometric sequence, but what's the rate of change called?
Common ratio.
We need to remember that if we think we have a multiplicative rate of change, it's called a common ratio. Because if I do a ratio of 9 to the previous -3, I get -3. If I do a ratio between 81 and the previous number, -27, what do I get? So I am repeatedly multiplying by -3. That is the ratio for a geometric sequence. And that's exactly how I did it here. I recognize, hey, I'm not adding or subtracting something consistently, but if I look at 80 and I do a ratio to its previous number, I get 1/2. If I look at 20 and I do a ratio to its previous number, I get 1/2.
Oh.
So what am I repeatedly doing?
Multiplying by 1/2.
That's all it is. I have to recognize what my rate of change is. As soon as I do that, everything falls into place really easily. It's a multiplicative rate of change, so it's a geometric sequence, right? And then writing these equations is essential to understanding how to get those in-betweeners that we were looking at with 2.4. Because I want you to notice, what output did I start with?
-3.
So look at my equation. Where did I start?
-3.
What was I repeatedly doing to that -3?
Multiplying by -3.
So I multiplied by -3. And you know that I'm multiplying by this, because how do we mathematically show repeated multiplication? See how it has an exponent? Why is that exponent a variable?
Because you don't know. You can decide whatever.
So you don't know exactly what it's multiplying, or how many times you're multiplying by -3, because it can change, right? That's the definition of a variable. Now this is an important detail. Why is it n minus 1?
So it's starting at the first, you can go down.
It's the same thing since the beginning, right? I'm starting at the first term. So I don't need to multiply by -3 one time, so n minus 1. In a very similar way, if I'm looking at number 4, what number am I starting with for my output?
160.
See how I'm starting at 160 over there?
Okay.
And what am I repeatedly doing to that 160?
Cut in half.
So I'm multiplying by
Half.
1/2. How do I mathematically show that I'm repeatedly multiplying? That exponent of n minus 1. We give it that idea. And it's understanding that multiplicative rate of change and how we show repeated multiplication that's going to be really important moving forward. Okay? Here's the next set of problems. Do I need to talk through any of these? This is based heavily on the work that we did with 4.5. Or 2.5. 2.4. Sorry, I'm getting all my different lessons and units mixed up. Alright. Which numbers do they give us for number 14? Where's your 2.4? How are you getting the notes on this if you don't even have 2.4 out?
They don't give us any numbers before time.
None at all?
Well, I mean, on years, but on the bacteria, no.
Okay. Oh, that's because it started at 2, I think, for all the bacteria. So every year it's multiplying by a factor of 4. So 2, 8, 32, 128. So how did I get these numbers in the middle? How did I get these numbers in the middle? Caroline, you paying attention with your head down?
Mm-hmm.
Pick that head up.
And multiplies by 3.
So with number 12, to go from 0 to 1, or to go from 2 to 6, it is multiplying by 3, right? It is tripling. 6 to 18. 18 to 54.
And 1.5 in between.
You think so?
Then
No,
you
probably
divide,
How about you do 2 times 1.5?
you multiply by, you try to get it, so.
3 times 1.5 is 3, I know that.
Yeah, 2 times 1.5 is 3, not 3.46. Now, so, and I do like what McKay is saying here, and I do want y'all to remember this, so when we come back to this in a second, when we looked at 2.4 originally, we played guess and check, right? But there was an easier way to do it, and that's what we're going to review a little bit to get started today. Notice, if I'm going from 2 to something to 6, and it's a multiplicative rate of change, is that common ratio going to change? No. Whatever I multiply 2 by to get here, I'm going to multiply here to get to 6. So what number am I starting at?
2,
What am I doing to that 2?
multiplying it by n.
Okay, you can do n, or typically if we're doing multiplicative rate of change, it's an r, right? And if I multiply by r twice, I get to 6. So 2 times r
Power 2,
squared is equal to,
and then 6.
Jeffrey, you paying attention, bud? You look like you're zoning out over there. We're 5 minutes in the class, you can't be zoning out yet. I need your attention on this, guys. This is fundamental to being successful on this. I'm starting at 2 bacteria, and then I need to recognize I'm multiplying by that common ratio 2 times to get up to that 6. Now that I have an equation, what can I do?
Divided by 2.
Okay, so solve it, dividing by 2. What is 2 divided by 2?
1,
And so r squared is equal to,
3,
and that makes sense. To go from 2 to 6, I had to multiply by 3, right?
cube it,
Hmm?
cube, square it.
It's already squared.
We gotta mark out that square.
So what's going to undo a square? Say it louder, Don.
Square root.
A square root. The square root is the inverse of a square. So r would equal the square root of 3. This is one of those defining characteristics of a square root. Okay? I'm going to talk more about this idea of a square root throughout today's lesson. But does that make sense how I can say, okay, I'm starting at 2, I'm multiplying by my common ratio twice, and so it's got to be the square root of 3 to get to this number. Okay? We can use that here for number 14 as well. Notice, what am I doing to go from this 2 to this 8? As a factor of 4.
You're adding 4. I mean,
Multiplying by 4.
Remember, when it has a factor, we're going to multiply, right? But I'm now trying to go in between here. So I'm starting at 2. Before I got this number, did you know what the common ratio was?
Yeah, it's
To go from here to here and then over there? So I'm pretty sure they only told you that the values in the table grow by a factor of 4 at each whole year. Did they tell you at half a year?
no,
No.
I think it's common sense.
Huh?
I think it's common sense.
It is, but is it always going to be common sense, or should we have a go-to method that always works? Caroline, up over
The
there.
go-to method.
Say again.
The go-to method.
Go-to method that will always work. Notice I'm starting at the number 2. When I did that earlier, what did I do to that number 2?
Multiplied by the common ratio.
Okay, but how many times did I have to multiply by the common ratio?
Twice.
Because if I multiply by the common ratio twice, I do know that I'm getting to what number?
8.
8. So 2 times r squared is equal to 8. So r squared is equal to 4, and then what would I have to do?
Square root.
And what's the square root of 4?
2.
2, right? 2, 4, 8, 16. So that one is more straightforward, but we have to recognize that we want a single strategy, which we should have been writing notes down about that strategy, because then we could refer back to it tonight for homework, because this is the second night we've had homework on this, which means tomorrow will probably be an accuracy check. Same way it's been all year. So I'll give you maybe 5 more seconds to maybe take some notes on 2.4. Gavin, do you just not have 2.4?
Oh, paying attention. If I get it right, I'm not gonna observe as good.
Yeah, but you might have something to refer back to later.
Yeah, maybe so.
Alright. So then I had you do 8 through 10 on this page. Okay, so use the graph of the function to find the desired values of the function, right? And explicit, that's your homework for tonight.
Wait, what is?
The number 11, where you have to write an explicit equation. So find the value of f of 6. If you ever see f of 6, what is that 6 be? What are you doing with that 6?
Multiplying it.
Are you?
You're starting with
Remember, it's usually f of
it.
n or f of x, right? That's function notation. That's not multiplication. It's not where you're starting. What is that 6 taking the place of? Well, if you're given a graph, you don't have an equation to plug into, but do you still have an x of 6? So I went to an x of 6, and I realized the output was 8. So 6 comma 8, so f of 6 was equal to 8.
Oh, wow.
That makes sense. So how did I say figure out that f of x equals 16 when x equals 8?
Go to what equals 16,
Well, so 16, is that on the x or is that on the y?
the y.
Notice it says f of x equals 16. So yeah, I had to go to 16 on the y.
X equals 8.
And if I bring that down, I see that x equals 8. Okay, so what do you notice about the way that inputs and outputs for this function relate? Create an input-output table if you need to. So all I did was I found the nice clear points. So 0, 1, 2, 2, 4, 4, 6, 8, 8, 16. How do you think I got this 10, 32? That's not on the graph.
We're multiplying by 2, so since 16 times 2.
Okay, so why is it 10?
You're adding 2.
Say again, Carolyn?
You're adding 2.
Okay, we need to recognize that it's not just something happening to my y's. Sometimes there might be something happening or a pattern happening to the x's as well. So for every 2 values of x, f of x doubles. So you might be tempted tonight for number 11 to write the equation f of x equals 1 times 2 to the x. That makes a lot of sense because where do I start? The input is 0, but what's the output? Remember, f of x is an output.
Or 1.
Start at 1. What am I doing to that 1? Multiplying by 2 repeatedly. So I've got an exponent there. Now it is just x, or you could write x minus 0 because it's the 0th term. However, if you check this, let's say I plug in a 6 for this equation. If I plug in a 6, do I get the 8 out that I'm supposed to? No. There's something wrong about this. So notice I've already given you a huge hint on number 11. That's a good place to start, but there may be something we need to do to account for the fact that we're adding 2 for every x. You could even think about the fact that it's 0, 1, 2, 2, 4, 4, so on and so forth. You might need to think about what would I need to do to find those values in between. It's based on what we did before. So that should be a huge hint to help you get started on number 11.
Times 0.5. Times 0.5 if I was in the middle. Yeah.
If I multiply 1 times 0.5, I get 0.5. Is that what's in between 1 and 2?
No, 1.5 is.
Multiply by 1.5.
If you put 1.5 here, you're adding 0.5. Is this supposed to have an additive rate of change?
No.
So think about what we just did with the last two problems. You need to find the multiplicative rate of change. Remember, you're going to be multiplying by some common ratio. 17 and 18, do we need to talk about these two at all? We went over these concepts before the Thanksgiving break. How to deal with a negative exponent and deal with the exponent of 0.
Go back over it. I kind of forgot.
What is 2 to the third?
8.
It's 8? How'd you get that?
2 times 2, 4, 4 times 2, 8.
So you multiply by 2 3 times? One detail, remember I added this in, and you want to keep this in mind? You start at 1, and then you multiply by 2 3 times. Everyone always says multiply by 2 3 times, but where are you starting, right? You got to start at a 1, so it doesn't change anything. 2 squared is 1 times, so 2 to the first, 1 times 2.
Okay, it's coming good now.
2 to the 0 would just be 1. And how many 2's would be there? 0 2's, right? And that doesn't mean we're multiplying by 0, it's just there are no 2's there. This is also why 2 to the negative 1, again I start with 1, but where a positive exponent is repeated multiplication, a negative exponent is repeated division. See, I'm dividing by 2 2's now? So, anything to the 0 power, what's it always going to be? 1. Whenever I have a negative exponent, what's that really telling me to do? What's a negative exponent telling me to do? To divide, which would also create the reciprocal. Because, and the reason I bring that up is if I have 1/2 to the negative 2, that would give me 1 divided by 1/2 squared, but how do you divide by a fraction? You multiply by its and so it'd be easier in that case to just go ahead and say, okay, I'm going to take the reciprocal rather than having to do the division. So a negative exponent indicates repeated division, which can create the reciprocal. Okay, couple of things I want to talk about. I'm going to talk through a couple of things that I do want to say, because I don't think any teacher can ever say this enough. But a little bit of appreciation and encouragement when it comes to the growth mindset. Just check in on y'all with your Thanksgiving. Review 2.4, the in-betweeners. Hopefully we'll get to 2.5 today. We'll see how it goes based on how that review for 2.4 goes. First things first. I know that this is a different style math class than what you're used to. Is that fair to say?
Yeah.
Just a little bit? Not for you, Devin?
Lot.
Lot? Okay. I know that it's different. I get that. And I do want you to understand, like, I do appreciate, like, y'all have adapted pretty well. You've learned to talk a little bit better. You're thinking mathematically better. And I don't want you to think that it's gone unnoticed. Is there still room to improve? Heck yeah. But that's the beauty of the growth mindset, why I have the growth mindset up here. I do want you to remember that it's not about being smart. It's not about who you are right now, it's who you're going to become. It doesn't matter how good you are at something right now. What matters is, are you putting in the work, are you putting in the effort to get better at it? And we're getting there. And I'm noticing it. We're getting better at talking with each other. We're getting better at mathematically thinking. We still have a good ways to go. But I want to encourage you on that, to keep fighting, to keep pursuing the idea of excellence, to continue pursuing mathematical learning and thinking. Not just, hey, I want an A, Mr. Kinney. That's not what it's about. If you focus on the growth and focus on the learning, you'll earn better grades. You will. I've seen it time and time again. You'll also find more satisfaction in the class if you focus on your growth and you focus on your learning, because it takes a lot of pressure off of you, because you're just wanting to improve and get better. So keep fighting for that. I will say we are getting towards the end of the semester, the end of the second 9 weeks, which means we're almost halfway through the school year. But also with that, we need to get some assignments made up and turn in some different materials. Anything that you have in the up here, and I need to add some more to it. That's a 0 in the grade book just because we haven't gotten it done. We got to get our stuff done. Otherwise, I have no other option but to put a 0 in the grade book. And that's not what I want. So I'm trying to give you a notification. Hey, let's get these things turned in. So make up your missing assignments. Get your homework done. 2 out of every 3 homework assignments is just, hey, did you put in the work to try something? I don't care what kind of career you're looking to do. The thing that you're always going to have to do, which no one ever wants to do, is you're going to have to work. You have to work to make money. Plain and simply put. And I know that some people look at like Instagram influencers, some people look at rappers, whatever, football players. Yes, they make lots of money. However, the thing that all of them have to do is they have to put in a lot of work in order to make that money. Don't care what you decide to do with your life after high school. You're going to have to work. We got to learn how to put in the work and do the homework. I need you to start trying to make sure that you are learning how to work. 1, 2, if you try the homework, when you come into class, you're going to be much better off to ask the questions that you need to ask so that you can learn the content better. The homework is a non-negotiable. We got to do it. But the last thing I want to say is, don't forget to keep growing. You keep growing and I will reward that. Your grades do not just reflect your mastery of the content. By the time we get there, your work ethic makes a huge difference as well, and your growth is what really matters. Learn from your mistakes, because mistakes are just opportunities to learn. They're opportunities to grow. Focus on that. Make sure that you do what you need to do in order to earn the grade that you want. I want to be someone who wholeheartedly helps you become the most successful person you can be. But I can only do so much on my own. Me giving you grades, me giving you hundreds, that's not going to help you be successful. Me supporting you to find your success, that's where it's at. And so please trust me. I know that I'm not perfect. I'm always looking to become a better teacher. But also I need you to try to meet me in the middle. Heck, I'll even put in 70-80% of the work if you can do 20 or 30%. But I need you doing the work. Your growth matters. Focus on that. All right. And then with all that, don't forget, we have 2 weeks of learning left, 1 week of exams. We need to put our best foot forward for the next 2 weeks.
When report cards come out?
After Christmas break, probably.
When, like, final grade period? When is the final grade period?
I usually, Ms. Hagler, correct me if I'm wrong, the final grades are due like the Wednesday after Christmas break or something?
Yes.
Yeah.
Excuse this interruption, we need Mona Lisa Hairston for checkout.
She is on her way.
Thank you.
Mona, we're gonna do a review of 2.4. I'm gonna upload the video, which, by the way, I did not get the stuff from last Friday uploaded because I left the, not flash drive, but the SD card, thank you, cannot think of that word. The SD card up here, but I uploaded it this morning and I'll have everything ready to go this afternoon. If you miss a day of school, make sure you watch those things. It'll help you. So we're going to review 2.4. Before we get to that and before we get to 2.5 though, how was your Thanksgiving? Anybody else feel recovered and slightly refreshed after a week off? Is that a no, Gavin? How are y'all not at least a little refreshed with having done no work for a week?
I still have to take care of stuff at home.
I mean, yeah, you still have to take care of stuff, but but you don't have any schoolwork to worry about.
It don't matter, my hours from school are bumped up to when I'm not going to school, and I still gotta do everything at home. The only difference is I'm not sitting in the cold
You're not sitting in the cold?
for the majority of the day.
Well, do your best to find balance. That's the only thing I can say. I know that there's always something going on, but you do have to find times to rest and recover. If you don't ever find those times, then you're going to get burned out. And if you get burned out, then you're never going to want to do anything. And it's tough. Trust me, I get it. But you do need times to rest and to recover. Find those for yourself. Find that balance. And please understand me saying that. Like, I'm 29 years old. I'm still trying to figure out how to find that balance. But I know it's a growth process. I'm constantly getting better at it. And so focus on that growth. Focus on trying to find that balance. Anybody else have a little bit better of a Thanksgiving? Is okay? Anybody have like a favorite food that they had at Thanksgiving?
Dressing.
Yeah, what?
Dressing.
Dressing? See, so my dad's from Jersey, New Jersey, and so he's all about that stuffing life, and that's all I've ever grown up with. And I can't do dressing. I love stuffing though. It's so good. Huh?
It's basically the same.
It's not though. There's like a huge like consistency difference and like the majority of what like I think dressing is usually made out of cornbread, whereas stuffing's usually out of I don't even remember what Dad puts in there, but it's not cornbread. It's a huge difference, man. I love stuffing. I hate dressing. I just can't do it. I don't know. That's just me though. Anybody else have anything favorite? No favorite desserts or anything?
Pecan pie.
Dude, straight up, pecan pie, man, that is where my heart lies when it comes to Thanksgiving and Christmas. If we don't have pecan pie, I am devastated. I love a good pecan pie. My parents love making that. I can't, like, there's something about there's just, yeah, whatever the cream of chicken, cream of mushroom, whatever's in there, I just don't like that. Can't do it. But mashed potatoes, I'm all about that life. Sweet potato casserole, I'm all about that life.
Some good mashed
Macaroni and cheese with bacon.
Okay, everyone today has talked about macaroni and cheese for Thanksgiving. My parents have never made mac and cheese for Thanksgiving.
What?
I know, like every student said it today, and I'm like, man, I'm missing out.
And macaroni
It's
and
like
cheese
the
with
only time
bacon.
we get real macaroni and cheese. And
Is it?
Yeah.
Every other time it's Velveeta shells and cheese or Kraft mac and cheese. Yeah.
Macaroni and cheese with bacon.
Mm.
Like,
Bacon.
I don't know. I'll have to look at that. Okay, so
Hot dogs. Change your life.
let's look at 2.4, the in-betweeners. We'll review this and then hopefully get started on 2.5. So I do want everyone's attention on this to recap everything we learned about 2.4 because this is going to drive a lot of what we look at for the next two lessons. Okay, so if you remember, we looked at this situation of 4 times 2 to the x, and so we started out with identifying the fact that we're starting at a 4 and repeatedly what?
Multiplying.
By
2.
2, right? So 4, 8, 16, 32, 64. We multiply by 2 every time. And so we plotted those points, and then we looked at this scenario with, I don't remember what his name was, Travis. So Travis said, hey, I think half the growth is going to happen in the first half, and then half the growth will happen in the second half. So we did 4, 6, 8, 12, 16, so on and so forth. But then we started to realize that these were creating linear segments. If it is an exponential function, should these things be linear? Remember, if it's exponential, it means we are repeatedly multiplying. But if it's linear, that means we're repeatedly adding. So if we have an exponential curve here, we should not be adding in between them. Does that make sense? And this went back to that 1.10 geometric meanies ideas. And so we commented on Travis's idea that it did not work. And then Miriam suggested they should fill in the table in the following way. I noticed that the function increases by the same factor, right? What do we do with factors?
Multiply.
We repeatedly multiply, right? And so when we looked here, let me show the work over here. So we looked at 0, 4. We already had 1, 8. Then we had 2, 16. And 3, 32, right? And this is the same thing that we already looked at, this idea, or that we looked at with the homework. If we're looking here at 1/2, do we know what the ratio is to get to 8 yet? Nope. But remember how y'all guessed and checked and played around with it a lot? And I believe when y'all played around with it a good bit, you got somewhere around 1.414. Does that sound about right, looking at your sheets? Yeah? So the reason, or the simpler way to figure this out, though, is this. We're starting at the number 4, right?
We're at number 5.
Yes.
1.415.
1.415 is what y'all said? Okay. But notice we're starting at the number 4. And then what are we doing to get to this term in the middle here? Do we know what we're multiplying by? Not yet. So I can use a variable r for common ratio. And then I'm going to use that same ratio to get to 8. So 4 times what? R squared is equal to 8. Right? Which that implies that r squared is equal to, not 4, 2, right? I'd have to multiply by 2 to get to 8. Which makes sense. It was 4 times 2 raised to the x. And then what would I do at this point to solve this equation? Square root. So r is the square root of 2. Anybody with a calculator? Can you do square root of 2? Say it helps to have calculators. Caroline, you literally have one on your desk. Gavin, you got one next to you.
Two,
1.41421. So y'all said 1.415 is very close. I've dealt with the square root of 4 or square root of 2 a lot, which is why I knew it'd be around 1.414. That's the only reason I knew that. But that's how we got each of those points. And if you kept multiplying by that square root of 1.41421, it got you very darn close to that 32 at the end. Which I think if you did 1.415, it was a little too much maybe, but not much. Does that sound about right? Okay? Now, one thing I want to point out to you about this is, you have f of x equals 4 times 2 raised to the x, right? Yeah, that's the function here. What type of function is this? It's an explicit. If you have an explicit equation, can't you just plug into it? Did anyone even think about doing that? But could I have done f of 1/2? That would equal 4 times 2 to the 1/2. Can someone do 4 times 2 to the 1/2 for us in their calculators? Say again. 4 times 2 to the 1/2. Get the decimal version of it. And this should be a note that you're making under number 5, because this is an important detail that you need to hold on to. Yasmin, what are you doing with your calculator? Are you doing this calculation?
No, I wasn't. I was dividing my paycheck up from last week to see how many hours I worked.
That's not going to help you with this. Somebody, anybody. One, it is an issue that only 3 of us in this classroom have calculators. 2, pick up a calculator and do something. At this point, it would have been a good idea for those of us who don't have calculators maybe to go get one. Man, laziness is a struggle. Say again, sir?
16?
You got 16? 4 times 2 raised to the 1/2. So make sure you hit that caret symbol.
5.65.
Okay, can you show Jeffrey, make sure he understands how you put that in? Notice how we got 5.66 right there? Could that just be rounding error in difference? Yeah? What I really want you to notice and understand about this is, that is the same thing that we got if we took 4 and multiplied it by the square root of 2. The 4's are the same, right? So what does that imply about this rational exponent? Notice we say rational just because it's a fraction. And this radical here. They're the same thing. This is foundational for what the rest of this unit is about. A rational exponent. And the reason we call it rational is because it's a ratio, meaning a ratio between integers, a fraction. A rational exponent is equivalent to a radical or root. This is fundamental to everything else we're going to do, and you need to make this note next to number 5, that a rational exponent is equivalent to a radical or a root. And I would have this notation here to show that. I'm going to go into more details about that in a second, after we look at number 6. So looking at number 6, notice we're still going from 4 to 8, so we're multiplying by 2, right? So I still need to find the common ratio, but now we're going by thirds. Any guesses what I would notice when we were going by 2, it was a square root of 2?
Cube.
So a cube root of 2 might make sense.
Cube root of 3.
Well, the constant factor is
2.
2, so it would be the cube root of 2 maybe.
Mm-hmm.
And so, looking at the cube root of 2, notice again, 4 times r times r times r. You see how I'm multiplying by that common ratio 3 times? And at the end of that, I'm getting to 8. All right, so r cubed is equal to 2. R would be the cube root of 2. Do we see how those ideas connect? Notice writing this equation, understanding that where I'm starting at, what my rate of change is, and what I'm ending at, makes this way easier to tackle and to approach. So my common ratio, or constant factor in this case, is the cube root of 2. Yes?
Mr. Key, we need to see Donovan Colvin for a minute.
He is on his way.
Thank you.
All right. From here then, I want you to notice that if I were to look at this detail right here, f of 1/3 would equal 4 times 2 raised to the 1/3, right? Which would be equivalent to 4 times the cube root of 2. We good with that idea? So again, we are seeing this idea that 2 to the 1/3 is equivalent to the cube root of 2. So a rational exponent is equivalent to a
Radical
or a root, okay? So how are the numbers from this exponent showing up in this radical? Where's this 3 showing up?
Cube and
The root, right? Tell me which root to deal with. So this is called the index. So the denominator of the rational exponent is the index of the radical. That tells you which root you're doing. So the denominator of the rational exponent is the index of the radical. It's a fundamental piece to recognize. Where do you think this 1 in the numerator is showing up? Isn't there an understood exponent of 1 on that 2? So the numerator is just the exponent on the base. And we're going to look at some more details with that moving forward, but that's an important thing to notice. Now, I want to point this out. If I were to look at f of 2/3, right, that'd be 4 times 2 raised to the 2/3. How would I write that as a radical, though? Which root would I be dealing with of that 2? Cube root. The denominator is my index, so it's a cube root. So it'd be the cube root of 2 being...
What's the next?
Say again?
2 in the exponent. What did
For a 2 in the exponent. We want to recognize how to convert from those rational exponents to those roots and back and forth. Does that make sense? So if I were to give you maybe the 4th root of 2 to the 5th, what would be the exponent there?
5.
That's it. All a rational exponent is another way to write a radical. Any questions about that so far? Do we understand how to find this constant factor here? Feel more comfortable with that? Do we understand how to convert between the rational exponents and the roots? No? Need some more work on that, Jeffrey? Okay. Remind me of that tomorrow. So we want to be able to identify the common factor, the constant factor necessary for defining the outputs of an exponential function, even when the inputs are fractional, and we want to connect radicals to rational exponents. Jeffrey, remind me of that tomorrow. Here's your homework. Make sure you take a picture of it if you're sprinting out of the classroom.
That was number 11.
2.4, ready numbers 5 and 11, set number 13, go numbers 19 and 20. This will be for accuracy tomorrow. Hey Jeffrey, come here real quick, buddy. So, okay. You're good.